Hello Gert, hello Eileen, everybody.
Bonnie.
How are you, Gert?
Good, thanks, and you?
I'm very well, thanks. I'm sitting here in my studio and there's a thunderstorm coming up, so I don't know if you heard the lightning just now.
Yeah.
So yeah, it's interesting. We thought it was autumn and now we're still getting rain and all of a sudden very high temperatures.
Yep.
But yeah, we won't complain. Eileen, I don't know how many people are there. I think it's just past 5 o'clock. Shall we start or do we wait a bit? Or...
I think for those that join on time, we should get going, and I'm sure the others will start dribbling in as we're going.
Yes, I agree. So Eileen, I don't know if you've got an introduction slide, or shall I maybe just introduce Gert to everybody that maybe don't know him, and then you can.
I'll just quickly share my screen. So I think, Donnie, for everybody, good afternoon, and thank you so much for attending today. We would just like to bring to your attention the ILASA Awards of Excellence will be taking place on the 10th of September. We have some exciting sponsorship packages available, and we are almost about to launch the criteria and submission information. So if you have any questions on that, please do reach out to ILASA Services at bdw.co.za or to myself, Eileen at bdw.co.za, and we can take the discussion further. Donnie, I'll leave it to you now.
Thanks. Yeah, welcome everybody. I think mostly ILASA members, but I think we also extended the invitation to SAGIC members. So everybody here, very, very welcome. It's our second webinar that Bosun Group is hosting. So Gert, very, very welcome to you. We're all looking forward to sharing your expertise. I think the previous workshop that you've held was very successful and very well attended. So we're grateful for your time and your willingness to host this webinar. And I'm not going to say much more. I think just generally from ILASA perspective, we engaged in a new approach by focusing on webinars, especially CPD events for our members, and to make it really fruitful to host events that are really learnful and that you can take a lot of things home to, and you can use that in your work, and you can produce better technical details. And so on that basis, we're also engaging with a wider spectrum of sponsors. So I think from an industry point of view, I think we are on a path that benefits both suppliers, specifiers, and our members. So Gert, over to you. Thanks very much again for your time.
Cool. Thank you, Donnie. Just before we start, we're going to have another one of these webinars in May, and you'll be glad to hear it's not going to be me presenting. It's going to be a real expert. So we managed to probably get the authority on permeable paving worldwide. So I'm really excited about that. So pencil in the date. I think it is it's the last Thursday of May. Like I say, it's going to be Dave Hine. He's a Canadian pavement engineer, but unlike engineering talks, his stuff is really interesting, and he's a really good presenter. So I'm really looking forward to that. But let's start. Let's get. Just want to share my screen. Can you see my screen?
Yes, we can. Thank you, Gert.
Okay, right. Thanks a lot. So today's subject is technical considerations when specifying paving. So like I explained last time, it is quite difficult if you can't see the audience. I don't know if you're sleeping or if you're finding it interesting or boring, or if you want me to move on or whatever. So let's try and be interactive please, if I'm boring, please just stick up your hand and say, please move on or whatever, and so that we try and keep it as interesting as possible. What we now, sorry, technical difficulties on this side. So we said after the previous webinar, we had a few requests. We sent out the form, and people responded, and they said what would they like to learn about next. And we took a few of those subjects, but before we get to that, let's just recap the basics, because you'll see today that many of the technical things, many of the things that seem to be quite difficult to get right is also rooted in the basics. So if we can really understand the basics, a lot of the more technical, a lot of the more difficult things when it comes to paving is going to become clearer to us. So this is what we work with. This is what you as landscape architects, this is what we need to contend with when we think about paving. I'm not going to go through the points. You can read. We know it's outside. We know there's movement. We know we need to contend with water. That's a given. Now, what we talked about last time are basically these 6 points, and we delved into a little bit more detail on all 6 of them. So just to refresh our memories, the first point, pavers, and I'm not using technical language, I'm just as simple as what we can say. We don't want pavers to move up or down, especially down. If you're going to traffic, pavers going to sink in, pavers going to settle. We don't want that, because as soon as pavers settle in an area, you're going to have a little dam, and that's going to attract water, or water's going to sit there. So how do we achieve that? Number 1, we have to remove the soft topsoil, the topsoil that contains organic material. We need to replace it with an inorganic material. We need to compact it, and that serves as the foundation of your paving. If we don't do that, chances are pavers going to settle, and that's what we don't want. The second aspect, pavers should not move sideways. So first one, don't want pavers to sink in. We also don't want pavers to open up. As soon as pavers open up, there's gaps. What's going to happen? Water's going to infiltrate. All kinds of other things that's going to lead to all kinds of other things. So how do we prevent pavers from moving or creeping sideways? We've got solid edge restraints to keep everything together. The next thing we need to consider is, where's water going to go? And there's 2 aspects to that. We're thinking of water on the surface of the paving, but also we know that there's some water that's going to infiltrate the system, and we need to deal with that. And something important is your bedding material needs to allow for this casual water that might infiltrate the system. And you'll see today that this is really, water and paving, they're not friends. We need to always think water. We need to think, where's the water going to go? And you'll see later on why I keep on emphasizing this point. So this one is straightforward. That's why we pave in the first instance. We want a smooth and even surface. How do you achieve that? Plate compacting and screeding. simple contracting 101. This is really important in the bigger scheme of things. And you'll see again, this is one of the points that we're going to refer to on our latest slides. Pavers should be locked in. Pavers, it's like a team sport, or it's a team. There's different components. You've got pavers packed in a specific pattern. They interlinked or interlocked with sand between them. It's a dynamic system. It moves. They work together. If you move them apart, you break the system. That's really, really important. We have to try and keep this whole thing together and interlocked and locked in. Because pavers alone are simply not strong enough. I've seen it time and time again. If you leave it up to the pavers only, they can't withstand the traffic. It's not going to last. Here we've got an example of pavers with no grouting between them, and you can see the consequence. Right, so one of the questions that came from the last presentation was, or let's just stop there. Any questions, any comments? It's just a revision of what we've done last time.
I don't see any hands or any comments, Kat.
Perfect. Right. One of the questions after last time was, how do I specify? How do I know which pavers to specify where and when? So it's quite a wide question, and you could have various answers to it. So I decided to keep it really, really simple. The first and probably most important consideration is always, is there going to be vehicular traffic? Are we going to have vehicles driving on this paving? And then there's two options. It's going to be commercial traffic, or it's going to be light traffic. So commercial traffic for us, in simple layman's terms, are there going to be heavier vehicles? Are there going to be trucks? Are there going to be lots of easels? Then you need something specific, and we'll touch on that on the next slide. If it's light vehicles only, you can get away with just a basic guideline specification, something in the lines of a base of 150 millimeters thick, at least a 50 millimeter paver in a herringbone pattern, sufficient. That's gonna be okay for an application where you've got light vehicles only. If you don't have vehicular traffic, then there's two options, and that's just something for us to think about, because sometimes I think we forget it. The first one is, could it be traffic? And I think that's where the developer would say, no, this pavement is only for pedestrian traffic. But if there is a chance that a vehicle could end up on this paving, it will happen. So whether it is a delivery of chairs for an event, whether it is a car showroom that's parking 6 or 7 cars at a shopping center, at the entrance of a shopping center, whatever, it is going to happen. So it is a consideration for a specifier to just consider all the options. Even though you might specify it for a for a pedestrian application only, there might be vehicles ending up on it. There might be cherry pickers, cleaning equipment, etc. And then there's the last option. It is absolutely impossible to traffic. It's impossible for a car to get to where the paving is. There's steps or there's bollards or whatever the case might be. So this is what we've got to work with. This is a simple, basic decision tree that we need to deal with. Now, let's just consider commercial vehicular traffic. And I'm just going to give you a few basic pointers. It's not from me. This is generally what engineers think about when they talk to us about commercial traffic or commercial vehicular traffic. So if we just think about it, let's take a shopping center or an office park. If you've got vehicles, if you've got hundreds of passenger vehicles driving over the paving every day, you've got trucks, you've got an occasional bus, you've got delivery vehicles coming and going, chances are that pavement endures more traffic than a municipal road and sometimes a provincial road. And we won't even, in our wildest dreams, we won't even consider building a municipal road without an engineer involved. So developers must really, really understand that if you've got commercial traffic, it is worthwhile getting an engineer involved, a pavement engineer, somebody experienced in the design of pavements, and because it's really key that you get your earthworks under the paving right. Because if your earthworks fail, everything's going to fail. Next thing that an engineer could help with really, really a lot is compaction. The base needs to be compacted to a specific level or a specific number, and it's really good to have expertise in that regard. When there's trucks, 80mm pavers are generally a given, and 80mm pavers, just for interest sake, it's not only that the pavers are stronger. This is something that many, even engineers, don't consider this. If you've got an 80mm thick paver, there's more, or it's a thicker paver, so you've got a larger surface area that's in contact with a larger surface area next to it. There's more sand in the joint between the two pavers, so it creates much, much better interlock between the pavers. That's something really, really important. Overseas, that is probably a more important consideration than the strength itself. It's all about the interlock. So a thicker paver gives you better interlock between the pavers. And if we now think back to what we said in the basics, it's this system working together. You don't want to break it. These pavers are dynamic. They're working as a unit. So the better interlock you can have between them, the better your performance, your long-term performance. So it's just something to keep in mind. Sometimes we forget about it. We think, it's only 20 mils. How much stronger can it be? It's not about the strength alone. It's about the interlock. Something that's for landscape architects probably quite boring, herringbone patterns, but for vehicular traffic, again, it gives you the best interlock. There's the least chance of things going wrong with a herringbone pattern. And then a flexible installation is recommended, which brings us to the next question that came from the previous webinar. Firstly, what is flexible versus rigid paving installations? That's the first question. What's the difference? The second question is, okay, that's all cool, but where would we then use a rigid installation? So let's delve into that. So flexible is where you install pavers on sand and you interlock them with sand as well. Rigid is where your pavers are bedded in mortar instead of sand. So what is mortar? Mortar is a mix of sand, cement, and water. So, and then the grouting is a rigid grouting. It is not flexible, it is not sand. So obviously, flexible is much more cost effective. Obviously, flexible is easier installation. Something to consider with a flexible installation, you've got access to underground utilities. With rigid, it's much more difficult because remember, now your paver is bedded in mortar. You've got a rigid grout between the pavers. So it's going to be more difficult to get to whatever goes wrong underneath the pavers. Another big consideration, flexible pavers can be trafficked immediately, where with rigid, you have to wait for the mortar to cure. So just a practical consideration. And generally speaking, flexible works better for small jointing gaps, where rigid, you have to, because you're looking at rigid jointing, your gaps between the pavers must be a little bit bigger than tightly packed pavers. So then the next question, when do we consider a rigid installation? So shall I ask the question, where would it be useful to possibly consider a rigid paving installation? Any ideas?
Anybody want to raise their hand or pop it in the chat? I see Donnie's hand is up.
Yep. That is actually interesting. We haven't actually used rigid installations, save for sometimes or for clay pavers. But all our concrete pavers up to now, we've just used a normal sand grout. But I guess if you use some of your products that are more like a tile, I guess you can do rigid installation. But our experience on that is that cement grouting normally cracks and pops out. So I don't know if it answers the question, but yeah, I don't specify rigid installations often.
Agreed, Donnie. It's really only for emergencies, especially in commercial applications, because it's more expensive in the first instance. But there's a few areas where you would do it. So the first area is if you're dealing with large pavers. If you specified larger pavers, and generally speaking, for vehicular traffic, you won't specify large pavers. But let's just take a step back. Where it's useful to do a rigid installation is if you use large pavers for a residential driveway. Because what could happen is a single wheel of a vehicle could end up on one paver alone. And if there's then turning involved, just think of the stress that paver is going to place, and that wheel turning it is going to place on the pavers next to it. So with a flexible installation, you've always got the chance, if there's a lot of turning, if there's a lot of heavy turning, You've got these large pavers on a residential driveway, slow turning, vehicles standing, turning their steering wheels. There's always a chance of movement. So for that, we recommend rather just fix it, put it in mortar, eliminate any chance of movement. And Donnie, like you said rightly now, if you're dealing with flagstones with larger grouting gaps, then a rigid installation is a given. You can't install it on sand. So there's some paving products that's specifically made. We will talk about this in a later webinar where we could consider what's the difference between flagstones and ceramic tiles, because there's definitely applications where flagstones would do a better job than ceramic tiles, but that's not for today. Small problematic areas. If you've got an area, so we've recently had a problem at a shopping center where a pedestrian crossing was demarcated with larger pavers, and it just didn't work because these larger pavers, the installation wasn't great, and there was movement, and these pavers kept on breaking. So a simple solution was to close off a section of the driveway and just reinstall those pavers on a mortar bed, grout it with a special grouting mortar that we've got access to. It's better than cement grouting. It doesn't crack, and that solved the problem for that shopping center. But that's a small area. It's literally just so it is an option. If a piece of paving keeps on failing, sometimes it's just better to say let's just in simple language, let's just glue these things down. Let's eliminate any chance of movement, and that will give us a solution to the problem that we've got. Another place where we could possibly consider a rigid installation is when we foresee drainage could be a problem. Then a solution could be, let's try and just keep water out of it. Let's try and waterproof the surface of this paving. Let's stick down the pavers. Let's waterproof the whole thing. Let's try and eliminate a sniff of water going into the system. So that's an option. One could think of that in specific applications where you foresee drainage or water being a problem. And then obviously you have to think about underground access, and that's one of the biggest drawbacks of a rigid installation system, apart from it being much more expensive. So does that answer the question of rigid versus flexible installation, and where you use, like I say, really emergencies only for rigid installation? Any comments, any questions around that? Right, so let's get into the meat of today. So problem areas, and we as manufacturer and you as landscape architect definitely ran into trouble at some point of our careers in the following scenarios. So there's a few, call it nature given circumstances and built circumstances. It's just more difficult to install or to specify paving for these, in these circumstances or in these environments. So we're going to go through them in a bit of detail, but what I want to try and do is link it back to the basics, because like I said, everything boils back everything boils back to the basics. And even with permeable paving, you'll see in May when we do the thing with Dave, still the basics apply. Even though it's permeable paving, even though it's installed differently, these basics are still key. So the first aspect, or the first problematic area, is paving on existing concrete structures. And it is, so what is an existing concrete structure? Any ideas? What kind of applications could it be? Where could you find, what's the most relevant place that you can think of? Kabelo? Was that a mistake hand? Or you muted?
Kabelo, did you want to say something?
Okay, seemingly not. Okay, so a practical application where this could happen is when there's an underground parking garage. So it's just something, it's one of the first questions to answer when you're specifying paving or when you're installing paving is there anything underneath? Is there a concrete structure? Are we working on top of a concrete structure? Because these are real world examples. This is what happens if you don't consider that you're installing paving on a concrete structure. It can be absolutely disastrous. I'm not saying there's not solutions for it. That's what we're going to talk about today. But we have to keep in mind, if you're installing paving on something like an existing, of the whole of Sandton, the whole of Mainland Main, for instance, there's areas that's just parking underneath. We have to consider it very carefully, or we have to consider how we specify our paving on top of these structures. The second thing that's becoming more prevalent in South Africa is, as space becomes more scarce, is rooftops. Rooftops, balconies, that's all little concrete structures. And there's ways of it. Again, it's not rocket science, but we just have to consider a couple of things carefully when we specify. So on existing concrete structures, there's two problems. The first one is water. If we think back to the basics of paving, water, paving's biggest enemy, could infiltrate the system. Just casual water, little bits here and there, because paving's generally crowded with sand, water to infiltrate. If that water doesn't have a clear path, if it doesn't have a clear drainage path to go to, that water is going to sit there, trapped between the concrete underneath and the pavers on top. That might create other problems then. So let's just think what could happen. Let's just apply our minds. What could happen if water is trapped between a concrete slab at the bottom and pavers on top of that? What would happen if a car drives over that paving, that waterlogged paving? Bearing in mind that the paving was installed on a bed of sand. So now you've got a bed of mud. What's going to happen? Right, so as you traffic these pavers with the vehicle, with the load, it's going to exert pressure on the pavers. That pressure is going to make the bedding sand that's saturated with water pump through the joints. And when that bedding starts pumping through the joints, it's going to remove the jointing that's between the joints. Compounding effect, then you're sitting with joints with no sand in it. So there's more space, more water is going to infiltrate, and it's just a compounding effect. So that's why it's really, really important. On a concrete slab, it's the first consideration. Where's the water going to go? It needs to go out of the system. So especially on a concrete slab, the drainage on surface level, yes, it's important. The more water you can divert, the less chance of water infiltrating the system. You could potentially try and waterproof your joints with a joint stabilizer. That will definitely help. But you have to consider, if there's water infiltrating the system, it needs to get out of the system under the pavers. So there's a few things, a few considerations. I think it's too much for today to go into the details of that. There's all kinds of guidelines. You're welcome to contact us. We've got access to various international guidelines. It's quite simple. It's quite clear what you stand to do. We're not waterproofing experts, but there's certain principles. If you just apply those principles and get rid of the water, you don't have this problem of a saturated bedding layer that creates all kinds of other problems. Now, the second problem with paving on an existing concrete structure or paving on a slab is a slab or concrete structure is designed to move. So there's two kinds of movement. The first one is just vibrating of the structure. If it's trafficked, etc., there's vibration. The second thing, it's designed to move. There's movement joints. Now, if you've got pavers that's installed, that's bedded in sand, that's grouted with sand, and it's installed on something that vibrates the whole time, you can imagine that the sand between the pavers is going to start migrating into the bed underneath. Again, opening up the gaps, more water could infiltrate the system. If the water doesn't have anywhere to go, compounded problem. The second thing is movement joints. So if you've got concrete structure, it's got a movement joint, and you simply pave over this movement joint, you're going to have a problem because these two slabs are going to move independently. It's going to be a lot of stress on the pavers between those two slabs. You're going to break the system. You're going to break the pattern. You're going to break the interlock between these pavers. So, in short, that is the problems when it comes to paving on existing concrete structures. Like I said, it's not problems that can't be overcome. Simple things. Firstly, engineer drainage. Second thing, respect the movement joints. So pave with the movement joints. Have edge restraints between the two slabs. Use a flexible sealant between these two edge restraints, and these edge restraints are generally, they use an angle iron just to keep the pavers concentrated on their piece of slab that's going to move. But if you've got a sealant between, it allows for movement, and you've got a little system that stays intact. Even though there is movement, it stays connected. It stays interlocked and problem solved. Okay, so generally speaking, what we say, if you're installing paving on a existing concrete structure, consult an engineer, or at least consult some guidelines provided on something like the Bosun website. It's not our material, we get it from overseas, so just speak to us. Something else that's becoming more relevant to South Africa is installing flagstones on pedestals on rooftops. What happens there is you've got little gaps between your slabs, which allows for water to liberally infiltrate the system and easily drain, get out of the system again without any other issues. So specifically on pedestals, because it allows you to easily pick up pavers if there's a problem with, say, waterproofing underneath, fix the waterproofing and simply just put back the pavers on their pedestals. But that again is a webinar on its own for a different day. We've got somebody from the UK that can present an excellent presentation on that aspect, because that's a subject on its own, is using pedestals and slabs on rooftops. That's it's a whole new world opening up for us in terms of space. Any questions, any remarks about concrete structures and paving on top of it? Donnie?
No, Gert, can you maybe just go back to your previous slide? Yeah, the image on the left. I think from my experience, that's the most common issue or problem that occurs with the paving on a concrete structure. And even though if edge restraints are used to minimize the size of the interlockers, it's just sometimes unimaginable that it can happen, because they're all packed when they install, densely closely packed within the concrete sort of frame, if I can put it that way. But in time, you still get this movement. But I think you've highlighted, or you pointed out the issue there, and that is only if the drainage is not sufficient. That's the only reason why this can start happening, or if the pavers were sort of just loosely packed and not properly back jointed.
Correct. You're right, Donnie. So it is. So again, just rules of thumb. You would. There's a few possibilities. It could be that, like I said, the movement joints. There might have been pavers that was packed over a movement joint, and that could have created with movement now, so the stress of opening up the pavers. The other option is, that as soon as it's more difficult, then it's always better to restrain your pavers in smaller areas. Although I know it's very difficult practically to do on site, but that is an option to just work in smaller areas and try and contain the pavers within those areas. Like I say, what they do overseas generally is they use other materials. They use metal, and it's not necessarily just concrete that you because concrete also brings a little bit of complications when you try and contain your pavers on a slab with concrete as well. So it is a complex thing, but it's not something that can't be overcome. But yeah, it is difficult, and like you say, it is common. And the problem is, once it starts happening, there's almost nothing you can do. It's just, yeah. Something else that you could potentially also do to prevent problems is you could use a joint stabilizer. Now, joint stabilizers generally in South Africa, most of them's imported, or the good ones in any case are imported. What they do is it's a urethane-based product, so it just seals off the joint. So it, number one, it binds the jointing sand to each other. It binds it to the paver, and it waterproofs the paver. So it is just a way, number one, to keep water out, and number two, to keep your sand intact. And that is a practical, call it a short or a hack to, I don't want to say prevent, because there's so many other things that could be problematic, but that is an option. And we have salvaged paving on concrete structures with specifically just with a joint stabilizer. I can think of Bogertman Pretoria's old offices in Brooklyn was one example where the joint stabilizer sorted out the problem. Right, now something probably even more common than paving on existing concrete structures is paving on steep slopes. Now, paving on slopes is, you often see paving failing on slopes. I talked about Bogertman now. I don't know how often their old office is in Joburg. This is where the picture on the left-hand side, it seems where Bogertman is situated, paving fails. But this is a classic example of paving failing on a steep slope. The right-hand side is at a residential complex in Waterfall. So there's, again, if we now think back, what's the major problems when it comes to the basics of paving? What's the major issues? Number one, water. We have to think water. And number two, this concept of interlock, this concept of keeping the paved system together so that everything's connected, that there's not gaps. Now, what happens with slopes, especially when there's vehicular traffic? On a slope, you've always got acceleration and you've got braking of vehicles. That puts enormous stress on the paving. So as a vehicle accelerates up the slope, as it brakes, as it comes down the slope, you can now imagine that might open up little gaps if the pavers aren't packed tightly together, if it's not contained tightly together. So what the guys say, or what the engineers say, is you have to have more frequent edge restraints if you've got a steep slope. So there's guidelines for it, but you could have restraints up to every 2 to 3 meters, depending on the slope, and that helps you It just helps with containing the pavers if there's lots of acceleration, lots of braking. But that's only one part of the problem. So that's good. That is really good. If we can eliminate that problem with having more edge restraint or more restraints, making smaller blocks of paving to contain, half the problem is solved. The second problem is we have to think back water. Always think water. So if there is a little bit of water that infiltrates the system, where's that water going to go? So that water is going to take the easiest path. It's going to go into the system because inevitably there's going to be some water that infiltrates the system through joints. That water then takes path of least resistance in the bedding sand, will go down, 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 down the slope. But now we constructed an edge restraint, a concrete curb. And now that water hits the concrete curb and it's got nowhere further to go. So now we've just created a little dam on our slope. So water infiltrates, even though it starts off as very little, that water drains down, hits the curb, got nowhere else to go, and then it starts damming up. And on the right-hand side picture, we can see where that water or that, so sorry, let me take a step back. I always forget to say that. So that water mixes with the bedding sand, creates mud, and that mud, if you traffic it, is going to pump out through the joints of your pavers, taking with it jointing material, which opens up bigger gaps. So you can see again, it's not a huge problem. It's not magic or anything. It's not, but we just have to consider there's water. So just a practical way, there must be weep holes in your edge restraints that allows water to go through. Obviously, if there's a weep hole, you have to have some form of a material that will allow water to go through, a geotextile or something that allows water to go through, but not the aggregate. And that will solve the problem, because then your water can go out and out of the system somewhere. And this is really what we found is the biggest problem when it comes to paving on steep slopes. And we've seen many examples like these two pictures. And again, not rocket science. Any questions, any comments on this? Right. The next one, I'm not going to spend a lot of time on. Paving adjacent to retaining walls. Just bear in mind that if you've got a retaining structure, again, thinking back, basics, water. There's lots of all the rainwater from the back is going to go drain, 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 drain. Can't go anywhere, can't come this side. Remember, the slope's always going to be this side because that's you're retaining something. So it runs down to where our car's parked here. So that water, when it hits, it goes underneath the retaining wall. The easiest path for that water to go is in the bedding sand underneath the pavers, and that's why these pavers are so discolored. So just bear in mind, right next to retaining walls, and you're paving, there's always a chance of water ruining the party. The same with steep inclines, long inclines. When your natural land slopes down, at some point, remember what's going to happen. It's not only surface water, it's underground water. It's going to follow the contours of the land. Where the land's going to flatten out, that water is going to start gathering, because it's all the underground water coming from the top together with the water naturally draining into the earth where the land's flat. So where you've got lots of underground water, where you've got high water tables, you've got all kinds of issues. One of them is discoloration of pavers. Similar clay soil, we all know that clay's got challenges when it comes to construction. It's not only the structural side of it, it is also aesthetics. Clay soil's got lots more minerals in it, and it discolors pavers. It's not good. So it is a consideration. So we're running out of time, but we've got a few practical things that I just want to quickly cover here. So where does it generally fail? So generally speaking, the most common places where paving starts to fail is when there's funny little things, when there's drains, tree holes right next to the edge beams. That's one side of it. And then the other thing is or it's kind of related, is when the pattern is interrupted. So these funny things interrupt the pattern, and that's where generally the simple failures occur. So just going to point out 2 or 3 just practical things for you to consider on site. So number 1 is around these funny things, around the drains, around the edge beams, when you've got, it's really, really important to think about the compaction of the base underneath. Because on the big areas, you've got mechanical equipment, you've got rollers, you've got mechanical compactors, you've got jumping jacks, you've got all kinds of things that are used for compaction. But around this drain, it's difficult. You can't go in there with a machine. And you hardly see a hand tamper on site. So it is important that around these structures, the base is really well compacted as well, because what you generally see is that's where it sinks in. That's where you start getting a little dam, water infiltrates, and because it's next to the drain or whatever, then it just compounds. You can see on the picture on the left that paving's definitely been replaced before, because it failed previously as well. So the second thing around funny things like this is you're breaking the pattern. So now you've got a nice herringbone pattern going with your paving. Now you're interrupting this pattern. So something really, really, really simple. Just make sure the contractor's cutting is as tight and neat as possible, because that's where the problem that creates problems. If the small pieces don't fit nice and tight, you're creating a problem for yourself, because there's going to be, again, water going in. That's where everything starts. That's where all your trouble starts. And once water gets in, it creates all the other problems. And I don't want to sound, paving is so forgiving. It's really, really forgiving. It's been done since, like I said in the previous webinar, since the Roman time. So it's not that I'm saying it's a disaster or whatever. It's just a consideration. Just these small little basic things will make life easier for us as specifiers and suppliers. Somebody asked a question specifically about tree holes. Now, the problem with tree holes is, again, we're breaking the pattern, number one. And then secondly, yes, it is, like I said, the compaction and stuff around it. Yes, it could be problematic. But with tree holes specifically, the issue is what they generally do, and this is a really, really good example. You can see that they bedded the edge of the tree hole in mortar. And the pavers are bedded in that mortar, and in theory that should create a restraint, an edge restraint. The problem is, number one, if we look at this mortar, it's literally just a little bit of mortar on top of whatever's been there. Let's assume they installed it on G5 or something. Now you've got this little piece of mortar on top of that. That's never going to be strong enough. So you have to have enough mortar that would contain your bedding and your base. So it must be a solid chunk of concrete that contains everything. Because what's happening here is eventually the aggregates from your bedding sand and even from your base is going to migrate into the soft soil of the tree ring or the tree owl. And that means there's no structure, there's no support under the paving. So, simple answer, tree owls, if you can avoid them, I would avoid them because it just breaks the pattern. But if you want to do them, make sure that it's underneath the paving is a strong enough structure to keep everything together under the paving so that it doesn't migrate into the soft soil of the tree ring. Or tree hole rather. And that is, yes, just a last example of a pattern being interrupted. It looks really, really nice, but with tiles, it's cool because tiles are installed rigidly. It's not going to go anywhere. When you've got flexible pavement, just bear in mind, if you break the pattern, there's going to be more movement, and movement creates, it creates problems with this teamwork between the pavers, the interlock between the pavers, the working together, the dynamics of the pavement. So just bear in mind, it's different. It's different to tiles, even though aesthetically it looks really nice. Right. Any questions? I really don't hope this was boring or I hope it added value.
Gert, yeah, I think from my side, I'm good. I don't know if there's anybody else on the floor that has got specific questions for Gert. I think everybody is on mute, so speak now, or I think everybody is probably thinking about dinner already. So if there's nothing else, Gert, I want to thank you for your time, for the very valuable lessons that you shared with us. And I think even if you've been working on paving for many, many years, there are always new issues that crops up. So I think one can never stop learning. So we really value your input, Gert. I think you've got a lot of knowledge on this subject. Yeah, if there's nothing else, I think we can we can conclude. Gada, I wanted to maybe just say on the beginning, I think everybody is also looking forward to a visit to the factory some other time as also an event that we would like to arrange. But I think that's probably still on your program for some time.
Yeah, no, for sure, Donnie. We always welcome people, and yeah, if there's any questions, I'm sure Eileen's gonna just arrange with the CPD points. I'm sure that's just gonna happen seamlessly. But if there's any questions or whatever, please feel free. And if there's any subjects that you want us to cover, please just send Eileen a message, and we'll get an expert. We'll get somebody from somewhere. Like I said, the intention's not for me to do the talking. We would like to get experts from across the world to kind of help us, because we're in the same industry. We want to develop this industry. So thanks, Donnie, everybody that joined today.
No. Thanks, Kat. Thanks, everybody. And we hope to see everybody soon on our next webinar.